Hello. This video is for anyone who wants to learn Python using math, or learn math using Python. It is also for anyone who wants to see how many math problems can be more easily solved by writing a Python program. Today, we will learn how to conduct any experiment with the help of a computer using only the internet browser, with Python. We will also learn to look at mathematics in a slightly different way. To achieve this goal, we will use 4 Combinatorics tasks from the school exam and write one Python program for each of them. First exercise: Park Maintenance Schedule. In spring, students from a school plan to participate in a park management campaign. With 3 parks and 5 available days, how many different park maintenance schedules can they create? Answer is 60. Let us now try to understand how the Python program works, which gives the correct answer. When we see a combinatorics problem, the first step we need to take, whether we solve it mathematically or programmatically, is to write down a few options on a piece of paper. So, let's say we have 3 parks, and let's try to write down some possible maintenance schedules for those parks. First schedule: Monday, Wednesday, Thursday. Second schedule: Wednesday, Monday, Thursday. Third schedule: Tuesday, Monday, Friday, and so on. This helps us answer an important question in combinatorics. Does the order matter? In our case, we see that it does. By writing down a few possible options, or answering this question, we have almost solved the problem and can move on to the solution using Python. How will we do this in Python? We will simply guess schedules many times, like 1000, and then look at how many different examples we have found. To generate random numbers, we will need the Python library random and the sample method from this library. The sample method takes 5 numbers, which correspond to our schedule days, and randomly selects 3 numbers from these 5. Next, we need a list to store our schedules. To generate 1000 random schedules, we need to create a loop. Finally, we will check if the randomly generated schedule has already been stored in the list of graphs. If not, we will add it to the list. Let's launch the Python program and see how it works. To start the program, we can look at the link below this video. The Colab environment requires us to be logged in with a Google account. After connecting to the Colab environment, the Python notebook opens, where we can find all the examples demonstrated in this video. I'll highlight the key elements of the code again. We use the random library to generate 3 random numbers from the list of 5 numbers. We will put the 3 numbers that represent our schedule into the schedule list, unique schedules. Every time a new schedule is generated, we will check if it is already added to the unique schedules list, and if it is not inserted, we will insert it. Next, we will simply execute these lines of code 1000 times and then print the result to the output terminal. With the first print line, we will print how many such schedules we managed to find. With the second print line, we will print the first 10 sample schedules. Let's run the code and see the execution result. As we can see, the code turned out pretty quickly. At the bottom, we see examples of park management schedules. We can see that using character string formatting parameters and emoji can produce a nice-looking table. It is important to note that we can view all our variables with their values and types by clicking on the X icon. We see that our index shows how many cycles have passed. We can see that 1000 cycles passed as the index varied from 0 to 999. Our variable that stores the schedule value has the values 154, which means Monday, Friday, Thursday. Also seeing the first values of your schedule list. We can see that the code is simple, and I recommend that you play around with it a bit yourself. This program defines a template that we can apply to many different math tasks. We can use this template not only to solve math exam problems, but also to solve math Olympiad problems. In the Colab notebook document, you will find the solution of several math problems using this template. Now let's take a brief look at the mathematical solution. The first question is what we want to select. The answer: we select 3 days out of 5. The second question is whether the order is relevant. Answer: yes. Therefore, we count the permutations and we get the correct answer, 60. Python can help us here too, since the math library has the function of calculating the permutations, perm. Let's continue to apply what we learned to the second task. Our second problem is called Music Club Performance Selection. The music club at school has 10 students, with 6 of them singing and 4 playing instruments. For an upcoming event, a group of 5 participants needs to be chosen, consisting of 3 singers and 2 instrumentalists. How many unique ways can these 5 participants be selected for the event? Answer: 120. Python's solution is practically the same as that of the previous task. We will randomly collect singing and playing students using the random library from 2 lists of integers that represent the 5 singing and 4 playing students. We will form a team by putting together 3 selected singing and 2 selected playing students. We're going to put that team on the list of teams. We will do all this in the loop 20,000 times. The only difference with the previous task is that the order of selection does not matter to us, and therefore, after selecting the elements, we must sort them. Math solution. What we select? 3 singing students out of 6 and 2 playing students out of 4. Is the order important? No, and that's why we use combinations. Python can again be used as a calculator, since the math library has a function for calculating combinations. Third time's a charm. Let's apply the same solution method to the third task and create an animated solution by extending our pattern. How many different 2-digit natural numbers can be formed from the digits 0, 1, 2, 3, 4, 5 if the digits in the number cannot be repeated? The question has a twist. 1 digit is 0, so it cannot be placed at the front. Python solution. We will use the same algorithm template as in the previous 2 problems. We will randomly guess 2 digits from a list of 6 digits. We will add the digits to get a double-digit number. We'll check that we've really got double-digit numbers and put it in a list of unique numbers. In this way, we will sample 1,000 times. With this problem, we can slightly modify our solution template in order to create an animation of the solution in a web browser. By replacing the for-statement line with a def update frame line and adding standard lines of code to create the Python animation. Let's see the final result of the animation. In the animation, we see a pie chart. Each loop of 2-digit sampling creates a separate pie chart showing how many unique 2-digit numbers we've sampled and how many are left to sample. At the bottom of the chart, we can see all the numbers that have been guessed up to the current moment. The mathematical solution to this task is that we count the permutations because order is important. And we do not forget to subtract 5 variants because 0 in front doesn't create 2-digit number. And we can use Python as a calculator. Our last problem has 2 subproblems and is a bit more challenging. However, we can use Python to solve it as easy as pie. 12 streetlights illuminate the street. 6 of them are lined up on the left side of the street, while the other 6 are lined up on the right side of the street. The first question: 2 streetlights are randomly chosen from the left side of the street. What is the probability that the selected streetlights are adjacent? As before, we will randomly sample by choosing 2 streetlights out of 6. We will try to sample 10,000 times. Whether 2 streetlights are adjacent, we will determine from the function check if it's good. Very often, various practical problems require us to take into account various constraints on the variables of the problem. To specify these constraints, we can create a function in Python and add it to our problem solution. The check if it's good function is just that element that we add to our Combinatorics problem-solving template. Function check if it's good is simple. We simply take the numbers of the two extracted streetlights and check whether the difference between those numbers is equal to 1. The mathematical solution of this first subproblem is quite simple. Since the order of streetlight selection is not important, we calculate the combinations 2 out of 5. There are 5 options when 2 selected streetlights are side by side. Therefore, the probability 5/15 equals 1/3. The second part of this problem is somewhat more challenging. In order to save electricity, it was decided to turn off a total of 5 lights on both sides of the street. How many possibilities are there to choose these 5 lights, such that no 2 off lights on the same side of the street are adjacent? The Python solution is, as always, very simple. We take a list of 12 numbers which define our streetlights. In a loop of 10,000 times, each time we randomly sample 5 numbers. With the function check if it's good, we check whether our random selection meets the condition of the problem, and if so, we add such selection to a set of good options. We can also animate this part of the problem by simply replacing the loop instruction with the draw function of the video frame. Let's take a look at the created animation, the implementation details of which can be found in the Colab notebook. In the animation, we can see on the x-axis how many times we randomly guess the options for switching off our lights. In the center, we show some good selected options. On the y-axis, we see the number of good unique variants that we were able to sample. We can see from the animation that somewhere around 4,000 guesses, we get to 80 good samples, and beyond that, we can't find any new ones. After seeing this animation, we can move on to solving the problem mathematically. On one side of the street, maximum 3 lights can be selected, and a minimum of 2. When 3 lights are turned off on one side of the street, there are only 4 shutdown options possible. When 2 lights are turned off on one side of the street, it is possible to have 10 different options. Therefore, the number of options is 80. Conclusion. In this video, we learned how to use Python to solve combinatorics problems. We also learned how to conduct experiments with the help of a computer using only the internet browser and how to animate them. I hope you enjoyed this video and found it informative. If you have any questions, please leave a comment below. Thank you for watching.